Hi, my name is Talia, and I'm an incoming high school senior who's super passionate about chemistry and math. I want to go into a career in education when I'm older, and I love helping people learn different subjects, specifically chem and math. I started this YouTube channel as a supplemental resource to anyone who may need help online with chemistry. I've been going in order of the topics I learned in honors chemistry. Last week, I talked about atomic history, atomic mass, and isotopes. And this week we are going to be talking about Bohr diagrams and ions. So if you need help with either of those topics, feel free to continue watching. And without further ado, let's get started. Okay, so we are going to start today by talking about Bohr diagrams. And you know from our previous video that electrons orbit outside of the nucleus. And basically, Bohr diagrams are one way of explaining where those electrons can be located in a two-dimensional form. So Niels Bohr discovered the orbitals that an electron is located in, and orbitals are synonymous with shells. Valence orbital is synonymous with valence shells. So you will hear me use those words interchangeably. And basically, each orbital has a specific amount of energy and can hold a specific amount of electrons. So the first orbital that's right outside the nucleus can hold 2 electrons, the second can hold 8, the third can hold 8, and then the fourth can hold 18. There are more and more orbitals, but these are the 4 that you will be working with for like basic chemistry. So basically, in a Bohr diagram, you illustrate the electrons and where they are on each orbital. Okay, so I'm going to show you how to draw Bohr diagrams in both the long way and the short way. With first sodium, we're going to write down how many protons, neutrons, and electrons the element has. So if you look at atomic number 11, so there will be 11 protons, 11 electrons, and then to get the neutrons, we can do 22.99 minus 11 protons, and we get 12 neutrons. Okay, so we have the basics of the atom. Okay, so we're first going to start with the long version. So in a circle that represents the nucleus, I'm going to move this over here. The nucleus, obviously has protons and neutrons in it. So I'm going to write that there are 11 protons and 12 neutrons. And then we're basically going to draw a circle to represent each orbital. And we have to put 11 electrons. But I'm going to draw my first circle, which will be the first orbital. And as we remember, the first orbital holds 2 electrons. So I'm going to put 1 here and 1 here. And I'm going to draw the second one. These circles do not have to be perfect. Mine definitely aren't. I'm going to put in 8. And I'm just writing E. And then now we have 10 total. And then I'm going to draw my third orbital. And there's only 1 electron left. So I'm going to just write one right over there. So that is our long version. Now I'm going to show you the short version, which is basically the same thing. We start by writing 11 protons and 12 neutrons, but instead of drawing a full circle, we're going to just draw a semicircle, and then each semicircle is going to represent 1 orbital, and we'll just write how many electrons each orbital has on the side. So the first orbital, as we see, has 2 electrons, and the second one has 8, and then the third one has 1. Okay, so that's our first example of drawing Bohr diagrams. Now give the nitrogen one a try on your own, and then we'll do it together. Okay, so let's do nitrogen. Nitrogen has 7 protons, which means it also has 7 electrons in a neutral atom. And to get the neutrons, we're going to do 14.01 atomic mass units minus 7 protons equals 7 neutrons. Okay, so now let's draw the long and the short version. We're going to start with the nucleus, which has 7 protons and 7 neutrons, and you can abbreviate protons and neutrons. And then for the long version, we have 7 electrons to fill. So we're definitely going to need 1 orbital that has 2 electrons. And then our second orbital, I'm going to write it out. If we have 7 We have 7 total electrons. We've already used 2 in the first orbital. Now we have 5 more for the second. So 1, 2, 3, 4, 5. That is our long version. Now let's do the short version. And so we'll have the first shell with 2 electrons and the second shell with 5 electrons. And together, this is 7. So that is how you do a Bohr diagram. Protons and neutrons on the inside and electrons on the outside basically just represents the location of the electrons in terms of which orbital they're in. Now we're going to look at the organization of the periodic table. So if you'll take a look at your periodic table, and if you notice in my last video, I was mentioning that there are both rows and there are columns. So as I wrote here, the periodic table is organized into groups, which are vertical, and rows, which are horizontal. There are certain correlations between the groups and the rows, and I'm going to start calling them groups and rows now instead of columns and rows. So the group number that the element is in is equal to the amount of valence electrons in a neutral atom. So as I wrote here. So for instance, chlorine is in group 7 and it has 7 valence electrons. And then the amount of orbitals in an atom is equal to its row number. So magnesium is in the 3rd row and it'll have 3 orbitals. So now we're going to practice by writing the group and the row of each element. If you look at oxygen, it is in group 2. Also, groups are written in Roman numerals and rows are written in Arabic numbers. Oxygen is in the 6th group, and it is in the 2nd row. Potassium is in the 1st group and the 4th row. Okay, so we are going to continue with a discussion of ions, and ions are basically charged atoms, which means that they have either lost electrons or given electrons, and that makes either their charge more positive or negative, because if you remember, protons have a positive charge and electrons have a negative charge, and the number of protons within an atom doesn't change. But when there are more or less electrons, the protons and electrons don't add up to 0 anymore. They might add up to +1, -1, stuff like that. So as you can see, every atom wants to fulfill their octet rule, which basically means that the atom wants 8 electrons in their valence shell. And this is true except for in elements up to carbon, because they lose electrons in order to have the first orbital with only 2 electrons be filled. So like for instance, all the noble gases, which are all the way on the 8th row, have 8 electrons in their valence shell. Like neon has 2 in the first, 8 in the second. So they are always stable. So ions just have a charge because they gain or lose electrons in order to fulfill that octet rule and get to 8 electrons in their valence shell. So an atom can gain electrons when there are already 5 or more electrons in the valence shell, because it's easier to gain 3, for instance, than lose 5, and it will lose electrons when there are 4 or less electrons already in the shell. So everything from the 4th group to the left will lose electrons, it will lose negatives and become more positive. Whereas from the 4th group on, it will gain negatives and become more negative. So a charged atom, as I mentioned earlier, means the number of protons does no longer equal the number of electrons. So the atom either becomes more positive or more negative. So there are names for positively charged ions and negatively charged ions. A positively charged ion is called a cation. And I always remember this by thinking cat ions are positive, kind of like a pun. And a negatively charged ion is called an anion. So where you might be wondering, like, where do atoms gain the electrons they need, or where do they lose the electrons they need? And that is where molecules come in, because atoms that need to lose electrons in order to have a full valence shell can give their electrons to an atom that needs the electrons. So let's look at, for instance, bromine has 7 valence electrons because it is in the 7th group, and it has a -1 charge, as you can see on your table. So it wants to bond with an atom that has an electron that it needs to lose because it can give the electron to bromine. So it might bond with potassium. Or in this example, I used sodium because sodium has an extra electron. And like if we draw the Bohr diagram for sodium, like we did earlier, there are 11 protons and 12 neutrons. There are 2 electrons here, 8 here, and 1 here. So sodium wants to lose the electron from this valence shell because it will then have a full octet in its valence shell because the third one will have nothing in it. And it can give it to bromine. So bromine and sodium might bond together and make NaBr. So I'm going to now show you how to draw the Bohr diagram for the neutral atom and the ion so you can see what happens when they gain or lose electrons. I'm going to only do the short version from now on. Okay, so we are going to start by doing an example with magnesium. Magnesium has 2 valence electrons and a +2 charge. So let's first start by drawing the neutral Bohr diagram. So we have 12 protons, 12 electrons, and then if we do the neutrons, we have 24.31 minus 12 protons equals 12 neutrons. So I'm going to draw the short version over here. We have 12 protons, 12 neutrons. Remember that the row number will tell you how many orbitals you have. So it's in the 3rd row, we're going to have 3 orbitals. So we have 2 electrons on this first one, 8 on the second, and we only need 2 more, which will be in the 3rd. So now you want to ask yourself, what does magnesium need to do in order to have a full valence shell with 8 electrons? It can either gain 6 electrons or lose 2. And it's obviously much easier to lose 2. So this is the neutral version. We are now going to show the ion with 12 protons, 12 neutrons, 2 electrons here, 8 electrons here, and the 3rd valence shell is gone because there's nothing in it. Obviously, those shells exist, but because there are no electrons in them, in the ion of magnesium, we don't need to draw it. So now let's discuss what happened to the charge. Magnesium lost 2 electrons. It has now 12 positive. I'm going to go plus 12, and it only has 10 minuses. And now that means it's going to have a +2 charge. So the positives outweigh the negative, and magnesium becomes a cation. Now we're going to try with bromine. Bromine has 35 protons, 35 electrons in the neutral atom, and for the neutrons, we want to do 79.91 minus 35 protons equals 45 neutrons. Okay, so let's draw the 2 Bohr diagrams. So let's start with the neutral one. We have 35 protons, 45 neutrons. So we know bromine will have 4 orbitals from the row number. So we have 2 here, 8 here, 8 here, and then remember the 4th orbital holds 18 electrons. So how many do we already have? 18, and we need a total of 35. So let's do 35 minus 18 equals 17, which means this orbital is going to have 17 electrons. So now to do the ion, it's much easier to gain 1 electron than lose 17. So our Bohr diagram will have 1 more electron in the valence shell and have 18. So I'm going to draw that out with 35 protons, 45 neutrons. So there will be 2 here, 8 here, 8 here, and 18 here. Now, we added 1 electron. 35 plus 1 equals 36 electrons. And we have 35 protons, so if we do negative 36 plus 35, we have minus 1. So bromine has a minus 1 charge, and it's an anion. So the octet rule, the only shells that need to have 8 electrons in them are the second and third ones. The other shells are exceptions, but you'll mainly be working with the first 3 valence shells, the first 3 shells anyway. Okay, so now we're going to determine the number of electrons in each ion. Okay, so manganese has 25 protons. It is number 25. And it has a 2 plus charge, which means that there are 2 more protons than electrons. So if you just subtract 2 from the amount of protons, you get 23 electrons. And we can check that by doing plus 25 minus 23 equals positive 2, which is this charge. Selenium has a minus 2 charge, and it has 34 protons, and it will have gained 2 electrons, so 36 electrons. Now you will notice that on your periodic table, the charges are written like minus 2 plus 4. When the charges are written by themselves, you put the sign in front of the number, but when they're attached to an element like this, you do 2 minus or 4 plus. Okay, so now we're going to try a table with ions, and I'm going to go through the parts you already know quickly. So first we have element number 74. That is tungsten with a symbol of W6 plus because it's an ion. The atomic mass is 183.9. There are 74 protons, and because there's a plus 6 charge, there will be 6 less electrons because it's a positive ion, a cation, which means there will be 68 electrons. For the neutrons, we can do 183.9 atomic mass units minus 74 protons to get 110 neutrons. Okay, now let's do arsenic. So look on your periodic table, it's number 33. The symbol is As3 minus. The atomic mass will be 74.92. And to get this symbol, I am just doing the chart. I'm just flipping the number and the sign. So I forgot to label my units. There are 33 protons. And because it's 3 minus, there will be 3 more electrons, so 36 electrons. And to find the amount of neutrons, we're going to do 74.92 atomic mass units minus 33 protons equals 42 neutrons. Beautiful. Keep in mind for isotopes, the neutrons change, and for ions, the electrons change because that is the charge. That's how you'll get a charge on the atom because neutrons are neutral. And yeah, just keep in mind when you have a minus charge, you're going to be adding electrons. When you have a plus charge, you're going to be taking away electrons. But that concludes our discussion of ions. So that was this week's video. I hope you enjoyed, and I hope you were able to clarify anything you might be confused about with Bohr diagrams and ions. Next week, I'm going to be talking about light and light calculations. So if you need help with that, you can watch that video. As always, I will be leaving a link to my website in the description where you can sign up for tutoring if you would like, and it will have all of my YouTube videos on there as well. Again, I hope you enjoyed, and if you have any questions, feel free to leave them in the comments. I will do my best to answer them, and good luck with learning your chemistry.